Hi, my name is Jiang. I'm the co-founder and CEO of Craft Health. So before we started the company, I was actually a pharmacist by training, where I practiced for a couple of years at a local public hospital. Fast forward, I decided to do my PhD and my MBA in the concurrent double degree program at the National University of Singapore. So that's where I did my PhD in drug delivery as well as formulation work, as well as an MBA with a specialization in finance from the NUS Business School.
Hi, my name is Seng. I'm a pharmacist by training, graduating in 2011 from National University of Singapore or NUS. I practiced in Singapore General Hospital for about 3 years as a pharmacist. After that, I moved on to doing my PhD in NUS as well, NUS Pharmacy, to earn my PhD in 2018. I am currently the co-founder and COO of Craft Health Private Limited.
Okay, so I did my PhD in drug delivery and formulation work. Predominantly, my research was looking at the drug delivery using exosomes and nanovesicles. At the point in time, it was something very novel and new, and that's what I found very interesting. At the same time, I also liked the commercialization of such research, so I actively joined a lot of programs organized by the university. For example, we have business case competitions, we have the Singapore-Stanford bio-design classes, and through that, I became even more interested in the intersection between research and commercialization. What about you?
So I did my PhD in specializing in the use of 3D printing for personalized drug delivery and testing systems. So basically, throughout the 4 years, we really explored various 3D printing techniques, such as maybe FDM, SLA, so on and so forth. Throughout the 4 years, we also developed novel materials that can help to improve the 3D printability of the different materials, as well as providing a specific release profile for it. I think what really caught my attention at the start of my PhD was that I did heard of 3D printing itself. It really gave me a lot of interest to see how we can build something out of nothing itself. So when I heard of this potential that 3D printing could be used in pharmaceutical dosage form, I immediately jumped onto it. Yeah, that's it.
So I met Seng Han, actually we know each other way back. In our final year of our graduate studies, we decided that we wanted to do something more than academic research. So we wanted to do something more translational. And a common pain point or problem that resonates with both of us goes back to the days where we were practicing pharmacy at the hospital. That's where we saw a lot of patients going home with bags full of medicines. So you have cholesterol, hypertension, diabetes medicines, what have you. And it can be quite complicated. 2 in the morning, 3 tablets at night, etc. And it can have before after food dosing. So we wondered whether there is an easier solution to it, and we brainstormed through quite a few different solutions. And then we realized what Seng Han was working on at that point in time could possibly be the solution. We obtained a small grant, tested out the tech. So at the time, it was very new. There were not many companies or groups that were looking to 3D printing for medicines. And that's when we realized that this technology could be utilized for a new application. Now going further, after we graduated, we went on to join the incubator at NUS called GRIP, Graduate Research Innovation Program. And that is where we talked to a lot of different stakeholders. We have doctors, administrators, nurses, pharmacists, patients, potential customers, pharma executives, and we realized that there's actually a demand for such a product. So going through the program, we spin off Craft Health, and that's where we have our Craft Health 3D printing platform, where we have 4 key segments. The first, we have our 3D printer, the hardware, what we call CraftMate. It's one of the world's first 3D printers specializing in the 3D printing of nutraceuticals or pharmaceuticals. We also have in-house developed a software solution that we call Craft Control, which is basically a 3D printing software for our 3D printer. We also have the third segment, and that's where we have the ink of what we print. We call it Craft Blends. Essentially, these blends have 3 characteristics. One, we source it from a list that's known to be safe. It's called generally regarded as safe from the US FDA side. We render it into a paste, so they are 3D printable. And lastly, through the different formulations, we're able to control how fast or slow a particular active is released. In other words, we are able to have a controlled release profile. And we collect the hardware, software, and the formulation data points into our database that we call Craft database. So this, in essence, is our Craft Health 3D printing platform. So a common question that we always get is, why 3D printing? So when we look at polypharmacy, or really too many medicines in a hospital setting or in a clinic setting, right? So that becomes an issue of pill burden, where the patients go home with too many pills, tablets, caplets, what have you. And the idea for 3D printing is that we are able to combine different medicines into one single polypill. Now, not only can we do that, we can also take into account the release requirements of each different medicines. Now, for example, we want a painkiller, right? A painkiller, you want it to be effective rather fast, so we can have an immediate release formulation. Once you take the polypill, everything is out within 15 minutes. Or let's say for a hypertension pill, you want to control the blood pressure within a nicely titrated range. So you want it to be released in a sustained release fashion, so you can have a release function of 4 to 6 hours. So it's released slowly in a 4 to 6 hours period. Or you can have a delayed release mechanism, just say a before after food. So you take the polypill in the morning, it's only released, let's say after 1 p.m, after you have your lunch. So the combinations are endless, and that's the beauty for 3D printing, where we can combine in different permutations and different assortments of active ingredients into just one polypill.
So I guess one of the patients that may actually benefit from such 3D printing technology would be that of my father. So my father has some of the common highs like general elderly would have in Singapore. So he has high blood pressure, high cholesterol, and then of course diabetes as well, high blood sugar. So in a day-to-day basis, he's taking about, if I last counted, it's about 9 different types of medication per day. So that adds up to about 15 different tablets throughout the day itself. So with such a technology, 3D printing itself, by combining different ingredients into a single tablet itself, taking into account the dose, release profile, or even the overall size of the tablet, we are then able to reduce these 15 tablets into one single tablet itself, potentially able to, of course, depending on the potency of each various active ingredient itself. Now, why do we think this is important? So really, a lot of elderly patients outside, based on our previous experience in hospital, they do complain that there are so many different medicines itself such that they forget how to take it, in the end not taking them correctly. So this leads to, of course, undesirable outcomes such as blood pressure not being well controlled, blood sugar not being well controlled. Now, what we aim to achieve by improving their compliance to all these medications itself, therefore, we are able to improve their health outcomes, improve their quality of life. Now, some of us as caregivers would also potentially benefit from all this technology as well. So at least for myself, every week I would have to actually prepare the medicine for my father. I mean, it's not difficult, but it does take some concentration from you, maybe about 15 minutes each time. And sometimes there are tablets that we need to cut them into half, cut them into quarter. Now, a lot of research has actually shown that cutting them into half or quarter, that's actually not very accurate. So 10 milligram, if you're going to cut into half 5 milligram, sometimes the tablet just crumbles and you're only getting maybe 3 milligram. Now with our 3D printing technology, that is not going to happen. It's going to be an accurate dosing, and it saves a lot of convenience to not just the patient, but also to caregivers like myself. Yeah, so I think 3D printing itself is really going to be a game changer to how patients are going to take their medications. And even not just for medications itself, it could also be used for a lot of nutraceuticals like our supplements, traditional medicines, things like that. Yeah.
So moving out of the lab into a startup environment, it brings a very strong or very vast change in different skill sets that we need to employ. So in the lab setting, we are using a lot of R&D skills, data crunching, how do we analyze the data. That is still required in Craft Health because technology is the core of what we do. But a startup is more than just the R&D. So when we came out and started Craft Health, we divided our roles. So for me, I was more outward facing. I deal with the fundraising, the investor relations, the BD, the accounting, the finance side. And Seng was in charge of the R&D as well as the operations. Now, being an entrepreneur, it really throws a bit of everything to you. So, we learn about how to manage the companies. We learn about, how to negotiate for certain contracts, the do's and don'ts. we also learn how to manage a team effectively. But that is what we typically see. What you don't see is the things that you have to do when things don't go according to plan. In some cases, we even have to fix equipment when, let's say, the aircon is leaking. We have to figure out why the aircon is leaking, right? So there's a lot of hands-on work, and it's really different from, let's say, a lab setting where you could perhaps have a lab manager and you tell him or her that I'm missing some inventory. But in a startup environment, you have to forecast that, I'm going to use up this amount of inventory. I need to get the best price. I need to take into account the lead time, and also be mindful of the vendor relationships that we have. So these are some of the, I would say, nitty-gritty details. They are small, but very vital in running a startup. How about you?
Yeah, I totally agree with Jiang in that transiting from a researcher into an entrepreneur, there's quite a bit of different skill sets that's being sort of involved in the day-to-day our operation itself. So previously as a researcher, I spent most of the time in the lab using my hands and legs to do the actual work itself, such as pipetting, transferring to a machine, things like that. But now I realize that I spend most of my time actually talking and planning. So what do you mean by talking is talking to my colleagues, talking to my staff, making sure that we are on track for certain progress in terms of research or the production itself. Not just that, as a researcher previously, I planned for my work 1 week in advance. Right now, as an entrepreneur, as the co-founders of the company, I think me and Wei Jiang, typically we plan up to 6 months to 1 year in ahead, especially for key capabilities itself that will allow us to actually venture into new markets. So really, I think the different level of skill sets is entirely different, I would say. Yeah.
Yeah. So to add on to that, we also need to be very nimble and very fast. So between the two of us, we make the decisions whether to go ahead or not to go ahead for a particular project or initiative or particular purchase. We need to do it quickly. So once we have a decision, we move along it. But sometimes circumstances change. For example, COVID hit. Right, so because of COVID, we had to slow down some of our projects. Some of our supply chain were affected. So we need to maneuver around or navigate around these unknowns and try to make the best out of the situation. So moving to a startup world is really trying to think of our 2 feet. Whereas if we are in the lab, at least we had the luxury of some time, right, before the new batch of supplies arrive, or we have ready access to certain equipment. But over here in the startup environment, we need to hustle for it. So we really need to be very nimble and fast in our approach.
I guess that what Wei Jiang mentioned is really one of the key challenges that we actually face. So supply chain itself is at the top of our mind, basically every day trying to find the most reliable and most cost-effective solution to getting our materials, getting our equipment itself. I guess one of the other important challenge that at least I feel that we face here in the company itself is really due to that of manpower. How do we hire the right talent and how do we retain the right talent itself? So not just by expanding or rather sending out our job descriptions, job applications to our warm contacts such as the universities. We also posted our jobs to public job domains like JobStreet, things like that, to really help us to cast a wider net to actually get the right talent into the company itself. We also offer competitive remuneration to try to actually keep the right talent, the best talents that we are able to get, and also offer staff welfare and medical benefits itself. Of course, right from the start, we think that a work culture can be a make or break to whether the right talent actually stays within the company. So right from the start, we wanted to keep a transparent, a very open, flexible, and a positive work culture itself right from the start. And hopefully our staff are able to appreciate all this. Yeah. What do you think other challenges that we may actually face?
So just to expand on the last point, I really think that culture is something that is very different from, let's say, in a lab setting and running our own startup. So previously when we were in the lab, we were under someone else. It's a prof, or we have other research fellow that we can work under. But in our own startup, we are the ones who are in charge of setting up the culture. So in the past, when it was just Seng and myself, it's relatively easy. You throw in more and more people. You have different people of different aptitudes, backgrounds, preferences, and things can be a bit more dynamic. So we try our best to have a very open, transparent culture, and the key thing is that we want is a collaborative culture, because what we are doing right here at Craft Health is the intersection between two big fields, 3D printing and medicines, and we need to have as much collaborative effort in order to have the best of both worlds. So why did I get into this STEM field? I think from young I was always interested in scientific disciplines, so that was a natural progression. I was interested in a rational approach to problem solving, and that's really what the scientific method embodies. So fast forward, to school, university, and eventually PhD, it's the same approach. And I think that has really, laid the foundations for what we do here at Craft Health. Yeah, how about you?
I think from young I thought that I didn't really like languages, so I didn't really do so much better for language as compared to my sciences, my maths, the STEM subjects basically. But then I realized that probably because of my interest for STEM, that's why I actually did better for that as well. And actually from young, my mother always told me, please go and do all your sciences so that you can get good jobs next time. So really I think what I want to tell the audiences is really just do it, do your STEM education, take up a STEM career. I think the STEM education really trains you to think logically and critically. So the technical knowledge that it imparts you is good, but really it's the thinking that actually allows you to open more doors, much more doors that you can possibly achieve down the road as you build your career. Yeah. Anything else?
Yeah. So I think it also lays the foundation for you to learn and to learn faster. So once you have the correct framework, the technical knowledge could be different, right? But it's really on how you assimilate that particular knowledge and apply it. So having that foundation really puts you in a good state to go forward, in terms of the knowledge assimilation and application of that knowledge. So this is our 3D printer that we call CraftMake. It's one of the world's first 3D printer that was designed for 3D printing of pharmaceuticals and nutraceuticals. So for this printer, it weighs about 90 kilograms. And the reason why it's so heavy, there are several actually. So all the wetted areas, that means the areas that are in contact with the paste formulation, they are either stainless steel 316 or they are medical grade. Another reason why it's so heavy is that it's designed for high throughput. So we've designed to 3D print about 3,000 to 5,000 tablets a day for 8-hour shift. And if you're printing that fast and it's not heavy enough, the entire 3D printer will wobble and lead to a lot of inaccuracies. So that's the reason why we have designed it to be that way for high throughput and stability. Another point to note is that if you look at our 3D printer, we use the technique of semi-solid paste extrusion. So what this means is that we formulate a paste similar to the toothpaste that everyone uses, but it's a more viscous form. We plug it into our 3D printer, and the paste is then pushed out by the print head, without any heat, without any UV or ultraviolet curing. So the entire process is done at room temperature and pressure, which means that we are able to incorporate a wide variety of different active ingredients, whether they are supplements, vitamins, or even active pharmaceutical ingredients. And the reason for that is that we don't use heat, we don't use UV. It's very gentle. So we do not foresee changes to the chemical structure. And to add on to that, after we have 3D print, we always do testing. Testing for the physical attributes, testing for the chemical attributes, to make sure that whatever active that we have incorporated is still there. So now we will show how we add in a pre-filled syringe. In this case, we have a syringe, then he added to the 3D printer, the print heads. So in essence, the paste which will be in the syringe will be then pressured by the air compressor that we have attached to the 3D printer. We'll pressurize the paste into the print head. And as a result, the entire print head will be full of the syringe. Now within the print head, we have another mechanism, basically a screw mechanism, to physically deposit or extrude out the paste material in the correct volume that we have pre-programmed. So the idea why we need these two mechanisms is that for paste materials, they are compressible. And for compressible materials, if we exert a force and then we stop, it will still continue to leak. If we are dealing with large objects, the leakage typically is not a big issue. But when we deal with smaller objects, in this case tablets, it will add up to a larger error margin. So we have a physical and a software approach to have what we call a suckback function, such that we reduce or mitigate this leakage problem. So in this way, we are able to have an accurate and precise dosing of the paste material in the required shape or geometry for the 3D printing process. So in this case, we have a 4-layer polypill that we have 3D printed, and you may wonder, how do we have a 4-layer polypill? So for craft make, we have a 2 print head attached in our 3D printer. So what this means is that we are able to do a concurrent 3D print of 2 different materials at the same time. This means that we can have the first layer of one particular active ingredient, and then the second layer on top of it for a second active ingredient, or a mix of active ingredients that are compatible. So how do we do the third and fourth? There are 2 ways. Either we swap out the entire print head to a third or fourth active ingredient material, or we can remove the tray and transfer it into another 3D printer for the third or fourth layer. So this means that the possibilities are endless. We're able to top up 5, 6, 7, 8, depending on what is required. These are our gummy bear formulations that we have been experimenting. So the idea is that we are looking to 3D print gummy bears formulation without the use of gelatin, and therefore without the use of heat. So this goes back to the ethos of what we do, a no heat UV-free method of 3D printing. So in this case, we have tested several samples and we have different shapes of gummies that are 3D printed with materials that are gelatin free, heat free and UV free. You're looking at a butterfly, a lion head, and some dinosaurs. So over here, we're looking at the different geometries, shape, color, design of 3D printed polypills. The idea behind 3D printing is that we are able to customize a wide range of solutions. So on the surface level, of course, things like color, right? It makes a lot of sense for, let's say, a supplement company, right, because of a marketing angle. And for medicines-wise, for color, it also helps, for example, 2 patients in a household to differentiate between mine and yours medicine. So it can be done that way as well. Shapes, in this case, we try to have certain shapes that fits, for example, a supplement or nutraceutical marketing angle, right? For medicines, not so much the shape is relevant. Now over here, you see a combination of 2 layers, 4 layers, and that's really to show that we are able to layer on top of each other different active ingredients that corresponds to different release profiles. So right here, we are looking at a different assortment of sizes that we can do with 3D printing. And this really is to show that for 3D printing, we do not have a mold. This means that we can change the size, the shape, whether you want a thinner, longer, fatter, shorter tablet. We can do it rather quickly. So what we're looking at is that we are able to also do what we call a pill-in-pill configuration. So in essence, what we do is that we 3D print a pill and encapsulate it within another pill. So from one end to the other end, you see 3D printed tablets that have a quarter of an orange tablet, half the orange tablet, and a full orange tablet within the white tablet. So why is this necessary? There are 2 reasons. One, we can use the geometry to control which active ingredient is released first. So in this case, the outermost layer is released first after consumption, followed by the orange layer. Or we can use this configuration for taste masking approach. So if you have an active ingredient that has an unpleasant taste, for example, a bitter taste, metallic taste, we are able to mask it by 3D printing a blank, or maybe a layer that has a sweetness or some flavoring to it to mask the unpleasant taste of the active ingredient. So over here, we're looking at beads, or what we call 3D printed craft beads. The idea is that we're able to print in a bead form, very small amounts of the active ingredient. For example, we can have a vitamin B3 in a bead form, We can also have vitamin C in a bead form. We can also have things like iron, as well as creatinine. And the idea behind it is that the user can just mix it up in the required dose by the weight, and they have a personalized concoction just for them. So every day they just need to mix it equally, and then they have a scoop where they scoop it up and drink it down with water or yogurt or something fancy that they like. So the idea is that now they have a personalized concoction just for the individual.